Example 6. An ordinary annuity pays 7.44% compounded monthly. A person deposits $100 monthly for 30 years and then makes equal monthly withdrawals for the next 15 years, reducing the balance to zero. What are the monthly withdrawals? Okay. All right, the question looks pretty short, but there is a lot going on here. Okay, this is kind of in part A. It's the whole retirement process, both saving and withdrawing. Okay, so there's actually two parts or two steps to the problem. Okay, so the first part is you've got to figure out how much money the person saves for retirement. Okay, so you're trying to calculate, I'll write this down. First part of the problem is you need to figure out how much the person has saved for retirement. Okay, and then in step 2, okay, once they have that, nest egg saved for retirement, you need to figure out what their monthly withdrawals can be if they're going to withdraw over a 15-year period. Okay, so let's work on the first part. Okay, I'll probably have to go to a separate sheet of paper because this is actually going to be a pretty much longer than the amount of space I gave you. All right, so let's deal with the saving aspect. Okay, so let's concentrate on what that says. It says a person deposits $100 monthly for 30 years, and that's about all it says for the saving part. Okay, because after that, it talks about the withdrawal part of the problem. Okay, all right, so this is an annuity. Okay, the person is going to be making monthly contributions to the savings account or to the retirement account. Okay, so since the person is saving money and doing so through regular deposits, you're going to have to use the future value of an annuity formula to figure out how much that person has saved for retirement. Okay, so we need to be using this formula for the first part of the problem. Okay, so this is a future value of an annuity. Okay, all right, so let's figure out what we know, okay, and what we need to calculate, and then we'll go from there. Okay, so basically we want to know how much the person has saved for retirement. Okay, so that is going to be the account balance. Okay, that's what we're looking for. Okay, how much, if this person makes the monthly contributions of $100 for 30 years at the given interest rate, how much have they saved? All right, so we should know everything else. P is the amount of each contribution, so that's $100 per month. Okay, R, the interest rate is 0.0744. You need all the digits there. Okay, M is 12. The interest is compounded monthly, and that coincides with how often the person is making deposits monthly. Okay, and time, they are saving money for 30 years. Okay, so it's going to be a 30-year process of saving money. Okay, so we can go ahead and plug everything in, and then we will be good to go. We'll get the account balance for this person's retirement account. All right, so let's go ahead and plug in. Okay, so it's going to look like this. Give me a second to plug everything in. All right, so here we go. All right, so this is how we're going to get the account balance. Okay, we just need to plug and chug into the calculator and get that answer. Okay, so here we go. Let's get the calculator out. Okay, so we need to start inside the brackets. Okay, and then start with the most complicated part. So inside the brackets in the numerator, we have 1 plus 0.0744 divided by 12 raised to the 12 times 30. Make sure that exponent is in parentheses because you can't do it in your head more than likely. All right, and then we need to do minus 1. Okay, that gives you the numerator of what's in brackets. Okay, hit your division key. In parentheses, put R over M. Okay, this gives you what's inside the brackets. Okay, and now we need to multiply all of that by 100. So we're going to hit times 100. Okay, and this is going to be the account balance. Okay, so let me write this down, and then we'll round. Okay, all right, so after 30 years, this person has $133,136, and then if we round, we have 99 cents. That's a 9 after, so we need to bump it up. So we're just going to say $133,137 even. Okay, so that's how much they have saved for retirement. Okay, this is not, I know I boxed it by mistake, but this is not the final answer to the question. Okay, because remember, we need to know what are the monthly withdrawals. Okay, so this is only the first part of this problem. Okay, so now you need to think about, okay, this person has saved $133,137 for retirement. Okay, now look at the flip side of the question, okay, which I'm going to highlight in pink. Now the person's going to start making equal monthly withdrawals for 15 years, okay, reducing the balance to 0. Okay, so now we need to figure out what the monthly withdrawals are. Okay, so let's go ahead and take a look at that aspect of the problem. Okay, all right, so I'm gonna need some extra paper here. All right, so let's think about what's going on here. So this is example 6A continued. Okay, so now the person has their nest egg and they're going to start withdrawing money from it once they have retired. Okay, so they're going to be receiving regular payments. They're going to be receiving, monthly withdrawals from this account. So it's regular payments and the annuity is being paid out. They're receiving the payments. Okay, so that means we need to use the present value of an annuity formula. So let's go ahead and write that down. All right. All right, so let's figure out what we know and what we need. Okay. The interest rate stays the same. It is 0.0744. Okay. Everything is still done monthly. Okay. This person's going to be receiving monthly checks out of this account. Okay. The timing has changed. Okay. So if you go back and you read the problem, okay, once the retirement part hits, which I have underlined in pink, they're going to take money out of this account for 15 years. Okay. So time has now changed to 15 years. Okay. So that leaves us with PV and P. Okay. So again, we need to figure out what these are and which one we're looking for. Okay. So think about it. You're trying to figure out what the monthly payment this person is going to receive out of the retirement account. So we're looking for the P value. Okay. So this is what we're looking for. The present value, the way you want to think of that, okay, is how much is in the account right now at the time of retirement. Well, it's this amount, how much the person has saved. Okay. That's the present value of the account. And then at that point, it will start paying out. Okay, so the present value is the account balance in the retirement account. So $133,137. Okay. All right, so again, you have to use a formula here because even though this is the amount in the retirement account, okay, the person will withdraw money every month. There's still money sitting in the account that it can accrue interest. Okay, so that's why you have to use a formula on this. Okay. All right, so let's go ahead and plug everything in. Okay, so we're going to get $133,137 is equal to our p-value times all this stuff in the brackets. All right. So there we go. Okay, so now we can just solve this for p. Okay, we need to figure out this quantity in brackets. Okay, and let's do that. All right, so again, we're going to enter it in, okay, as we see it. Okay, start with the numerator because it's the most complicated part. Okay, so we're going to get, let's see, we're going to get 1 minus parentheses 1 plus 0.0744 divided by 12 raised to the negative 12 times 15. Okay, there's the numerator. Okay, then you want to divide by r over m, so we're going to hit division. Okay, put in parentheses r over m. Okay, this is the quantity inside the brackets. Okay, so the right side is going to be P times this quantity. Okay, all right, so that's got to equal the $133,137. Okay, and then if you want P, the amount of the monthly withdrawal, okay, divide both sides by this number. All right, so let's figure out what that is. Okay, so all we need to do here is just take the $133,137 and divide by this previous answer. Or if you type it in, make sure you use all the digits. Okay, so that's going to be the monthly withdrawal. Okay, so let's see, let's write this down. $1,229. Okay, so let's take a look at that. We've got to do our rounding. Okay, so there's the p-value. Okay, so if we round to the nearest cent, okay, we have 66 cents and there's a 1 that comes after. Okay, so we're going to keep it 66 cents. So the person can make monthly withdrawals of $1,229.66. That is the final answer for part A. Okay, so that was a very lengthy process because in part A, you actually went through the whole retirement process. You had to save the money, okay, to get an account balance at the time of retirement, and then start withdrawing the money, okay, over a different time period, okay. All right, let's take a look at part B.